Calculate resistors in parallel. A resistor is a device designed to introduce resistance into the electric circuit. In layman's term, a resistor can be described as the thing that keeps the balance of electric circuits. Without this, the circuits will not learn where their limitation is and there will be unbalance, faulty, and chaotic electrical system. Besides having resistors, knowing how to calculate the voltage in every resistor that is in parallel is also important. Logically thinking, parallel branches should have equal voltage running across them. So, there is no need to compute for the resistors in parallel since the voltage is equal. However, this is not always the case. In series resistors, the total resistance is computed by adding the resistance together. Parallel resistors, on the other hand, are more complicated. Two resistors calculating more than two resistors in a parallel uses a different formula. A simplified form of that formula can be used to compute two resistors in a parallel. Req equals R1 R2 _ R1 plus R2. For example, R1 equals 5 ohms, R2 equals 6 ohms. This problem is computed through the following solution. Req equals R1 R2 R1 plus R2 equals 5 ohms, 6 ohms. 5 ohms plus 6 ohms equals 30. 11 equals 2.73 ohms. Therefore, the power of resistors in parallel is equals to 2.73 ohms. More resistors. What if there are more than two resistors in a parallel? In that case, the formula below should be used. Req equals 1 underscore 1 underscore 1 underscore 1 underscore 1 underscore R1 plus R2 plus R3 plus Rn. Try this formula using the given values. R1 equals 4 ohms, R2 equals 6 ohms, R3 equals 8 ohms, R4 equals 10 ohms, and R4 equals 12 ohms. Req equals 1 underscore 1 1 underscore 1 1 underscore R1 plus R2 plus R3 plus Rn equals 1 underscore 1 underscore 1 underscore 1 1 underscore 1 underscore 4 ohms plus 6 ohms plus 8 ohms plus 10 ohms plus 12 ohms equals 1 underscore 0.25 ohms plus 0.17 ohms plus 0.125 ohms plus 0.1 ohms plus 0.08 ohms equals 1 underscore 0.795 equals 1.26 ohms. Therefore, the power of the resistors in parallel is 1.26 ohms. More formula. The formula for calculating the resistors in parallel that are mentioned above can only be the start of solving a new equation. Even the data given above can be used to solve a different equation. Solving the voltage divider or the current divider principle is possible with those data. To get the voltage divider, get the product of the first resistor ohm and the voltage. The answer will be divided by the sum of the first resistor and the second resistor. To get the current divider principle, multiply the current by the quotient of resistors in parallel and its first resistor. Enough practice should help you familiarize the formula better. Take note also that the examples and formula mentioned here are the basic and the simplest. In real-life scenario and more complicated problems, a more complicated formula is also needed. A little imagination and creativity will help you solve the problem easily. After all, even the most complicated math problem can only be solved after you have learned the basics. So, never underestimate the power of this simple formula. It could get you far into solving more challenging problems.